Hi there. In this video we are going to prove the law of cosines, which is an interesting law because it extends the Pythagorean theorem to non-right triangles. So let's take a look. So here we have a picture of two triangles, neither of which are right triangles. And what we want to do is find a relationship between the lengths of the sides of these triangles. And what you are given here are the lengths of the sides as variables, but also an angle here. So we're also going to incorporate this angle into the formula. The way we're going to do this is we are going to form a right triangle by dropping a vertical from the top point of the triangle. Now you can see there's two situations. One where we have an obtuse angle here, in which case the vertical is outside the triangle. The other one is where we have an acute angle, in which case the vertical falls inside the triangle. All right, so what we're going to do is we're going to focus on the little right triangles that we've formed by dropping down the vertical. All right, so we have this right triangle here with hypotenuse A, and we have this right triangle over here with hypotenuse A. Now, the height of these triangles is given by b sine alpha, and that's the case in both of these pictures. Now, if I call the length from the start of the angle alpha all the way out to where I dropped the vertical, if I call that x, then I know that this distance is equal to x minus c. And in this picture, this distance is equal to c minus x. So what we're going to do is we're going to apply the Pythagorean theorem. All right, so we know that the sum of the squares of these two sides is equal to the square of the hypotenuse. Now, one thing to keep in mind is that this distance over here is x minus c, whereas over here it's c minus x. But when you square it, you get the same thing. So it doesn't matter. This equation corresponds to both of these pictures. And if I expand these out, I get the following. Now, what is the quantity x? Well, x is equal to, from basic trig, it's equal to b times the cosine of alpha. And now we can use the Pythagorean identity for trig functions. I know that cosine squared alpha plus sine squared alpha is equal to 1. And here we have it multiplied by b squared. So these two terms combine to give us just b squared. So that takes care of this and this. We also have a plus c squared. And we have this term. I'm going to put the c over here. And this is the formula that we need. This is the formula from the law of cosines. Now, the law of cosines has not only this formula, but two other associated formulas treating each one of the possible angles in the triangle, and you can prove each one of those exactly the same way, simply by rotating the triangle around and treating a different side as its base.